Hey guys, welcome to my channel Medicinal Pharma Education. Here we are going to discuss about the NMR spectroscopy in this video. In the previous video we have completed quantum number, their roles in NMR, and principle we have discussed. Instrumentation is already done. Next, the solvent requirements in NMR and relaxation process and NMR signals of various compounds. These are the topics that we are going to discuss in this video. Okay, if you have not seen the previous videos, please watch them so that you can understand the concept in more detail. Okay, uh, and once again, welcome guys. Here I'm trying to educate students for M-Pharmacy, and as well as myself I'm preparing for M-Pharm. And let's not waste time and start the topic. Okay, firstly, solvents. What are the ideal properties of solvents? Okay, I think so the camera is okay, good. What are the solvents in NMR? Ideal properties of solvents are they chemically inert, they should not react with the other substance, and they should not react with the sample. Magnetic isotropic means the magnetic effect on the solvent should be uniform, it should not show different. Okay, it should be like similar. Okay, next, volatility to facilitate sample recovery. It is meant by, like, if the sample it needed to be recovered, then the solvent should be volatile. Okay, volatile in nature, so that we can separate the solvent based upon the difference in the melting point, or boiling point, difference in the boiling point. Okay, next, it should not contain hydrogen atoms. If in NMR we already discussed, right? Hydrogen atoms, if the solvent contain hydrogen atom, it interacts with the signals of the sample, so hydrogen atom should also be not there, should not be there. Okay, and it should be inexpensive. That's the ideal properties. Next, most common solvents are used are CCl4, DCCl3, and D2O, CDO, CD3OD. Okay, next, CD3SO. These are the main solvents or common solvents used in the NMR spectroscopy. Next, here we are going to discuss some points. Deuterium signal will lock and stabilize the magnetic field in the modern NMR instrument. See, the most common is deuterium. It locks and stabilizes the magnetic field in modern NMR instrument. These signals are also used to shrink the magnetic field. Okay. Next, sample of higher viscosity benefits from dilution with mobile solvents. Okay, see here, if the sample is higher viscosity, if the sample has higher viscosity, we can directly dissolve in the solvent, because we have to dilute it, right? We can directly dissolve in solvent, and it dissolves and it also diluted. Okay, this is the advantage if the sample is higher viscosity. Selection of solvent in which the sample is 10% soluble. Okay, we have to select the solvent in which the sample is at least 10% soluble. Okay, these are the some properties. Okay, next we are going to discuss with uh, relaxation process, which is very important. And let's continue the relaxation process. Okay. Guys, tell me if the flashlight is working or not. If it's disturbing me, from the next video I'll just off it. Okay, because the light which I use in my room is not emitting enough energy, so the videos are like a bit dark. Relaxation process involves some non-radiative transition by which a nucleus in a upper transition state returns to a lower spin state. See, relaxation process, what is meant by relaxation? First, in common terms, what is meant by relaxation? Relaxation is uh, calming ourselves. If we are running like 100 meters, right? If you are running like 10 kilometers, after 10 kilometers, we just relax, right, for a bit of time to regain the energy. That is called relaxation. Okay, relaxation nothing but to remove the stress. Okay, to remove the stress from the body. That's the relaxation. Here, the relaxation in the nucleus is remove the energy. By removing the energy, relaxation occurs in the nucleus. That's what telling. See, in an upper transition state returns to a lower transition state. Upper transition means higher energy, and it is removing the energy and coming back to the lower spin state. Okay, there are types of relaxation process. Okay, mainly there are three types: spin lattice relaxation process, it is also called as longitudinal relaxation process. It's also called as spin cooling relaxation process. Okay, and second one you have spin relaxation process, and the third one we have quadrupole relaxation process. Okay, we'll go through one by one each. Firstly, spin lattice relaxation process. Here, lattice is another molecule, involves transfer of energy from a nucleus in excited state to a molecular lattice, example solid, liquid, gas. The nucleus returns to ground state and the lattice gains energy. Here, and molecule, this molecular lattice absorbs the energy in the nucleus, and after absorbing, the lattice gains energy and nucleus returns to the ground state. That's the basic concept. Nucleus returns to the ground state and lattice gains the energy. By this, nucleus causes relaxation. This is the basic concept. Understand this. It is denoted by T1. Spin lattice relaxation, it is denoted by T1. Okay, sharp signals are obtained if T1 is greater than 1. Sharp signals are obtained. Okay, if T1, the energies energy transfer T1, if it is greater than 1, then sharp signals are obtained. Energy consumption in vibrational rotational changes in solvents and other molecules. As the solvent changes, the energy and rotational and vibrational rotational charges also changes. Okay, this is the diagram you have to draw for a spin lattice relaxation. Okay, it contains three axes. It sends the energy to the spin lattice. Okay, this is just the diagram. You can just draw in exam to impress your teacher. That's it. There is nothing that spin transfers. Here it involves a mutual exchange of spin between an excited nucleus and a neighbor molecule without altering the spin status of the system. See here, it is like transferring to the another nucleus. Okay, see, mutual exchange of spin between the excited nucleus and other neighboring nucleus. Here the energy is exchanged between two nucleus. Okay, without altering the spin status of the system. See here what happens if T2 is larger, sharp signal is obtained in liquid and gases. In T2 is small, then bordered signal. What is different between large and small? See, large signal means a sharp signal where you can directly identify. Small means like it's not enough to identify the compound. That's the shorter signal. Okay, this is the relaxation. Relaxation means remove of energy. Next, third type, quadrupole relaxation. This is very important. It is the prominent relaxation process for nucleus having I greater than 1 by 2. We also know that quadrupole, if we have from the previous videos, we know that I means quadrupole number, where it describes the some energy. Okay, if it is 1 by 2, then the spin exists. Examples here, nucleus such as N14, nitrogen 14, oxygen 17, and boron 11, due to isotropic intensity. Isotropic interactions means small same. Okay, I have written small. Same in all directions. Okay, between a non-spherical electrical quadrupole nucleus and electric field, a gradient at nucleus caused by electric environment possessing an asymmetric positive charge distribution of the nucleus. See, this line you have to by heart, but I will explain what's the meaning of it. Example, see, if you just think this is a balloon which is non-spherical. Okay, balloon here means nucleus. Okay, non-spherical electrical quadrupole nucleus. This is non-spherical electrical quadrupole nucleus. Okay, here it contains a fan, or it is also called as electric field. When the fan is rotated, right, when the fan is on, there is an which air falls on the balloon, and this balloon, okay, shake will shake, right? If air is blown, the balloon will automatically shake, it will shake, right? In the same way, electric environment is applied to the this nucleus, okay, non-spherical quadrupole nucleus, where it shakes and releases the energy out. Okay, I will explain the diagram. This is the basic concept. The electric field is applied on the non-spherical quadrupole nucleus. Okay, here it causes the electrical environment, okay, and this contains positive charge distribution on the nucleus. It contains positive, we already discussed, contain positive, see, asymmetrical positive charge distribution on the nucleus. See, asymmetrical positive charge on the distributions. Hence, this nucleus exhibit electrical quadrupole movement and relaxes rapidly as displays very broad signals. As it shakes, right, it emits out the excess energy and it comes back to the ground state. This is called quadrupole relaxation process. I think so you have understood. If you have not understood, just rewind the video and just understand the balloon example. I have also not understood this topic, but I have gone through some examples and then I have got this topic. Okay, if you have not understood, just go repeat it, you will understand it. Next, NMR signals of various compounds. This topic is quite lengthy, but it may occur in the exams. They can directly discuss about the NMR signals of various compounds. Then you have to write this. Okay, a number of NMR signals represent the number of protons in a molecule. See, NMR signals are directly proportional to number of protons. This is the basic first thing. Think NMR signals and number of protons, they are equal. Here we'll take some examples and discuss how the signals are emitted. See, here there are 3 protons and here 3 protons, but see the surroundings. The signals are based upon the surroundings and environment of the protons. Here all equivalent H's. Why we are telling that it is equivalent? Because see, here we have 3 atoms, 3 hydrogens which are attached to carbon. Here also we have 3 hydrogens we have attached to the carbon. Okay, and this carbon attached to oxygen, this carbon is attached to oxygen. All these 6 protons are similar. If you take here one atom, it is similar to this one is similar to this one, so we call as quadrupole. If every 6 protons are similar, if all the hydrogens are similar, then it is one signal. Okay, if it is another C, then it is different. Okay, we'll see in the second example. Here 3 hydrogens and here 2 hydrogens and here chlorine is there. See, here 3 hydrogens are attached to carbon, here also 2 hydrogens are attached to carbon. Okay, what is the difference? Here beside is carbon, but this carbon is beside is nucleus, so these two are different. Okay, different, right? Then this one is HA and this one is HB. Okay, we take sum of all the carbons, all the hydrogens in a carbon. Okay, then here from this we can understand that there are 2 type of H's, 2 NMR signals. Okay, and third example, see the third example, you can understand better. Here there are 3 types, 1 2 3. Here 3 types of protons are there, but see, carbon attached to next atom is oxygen. This is one type. Here one side is oxygen, one side is carbon, so it is also different. Here one side is carbon, but there is no oxygen, so this is also different. Here 3 types of protons are used. Okay, next there are 3 types of signals. Sorry guys, the phone is a bit hot, so that the flash is off. I think so you were able to see. Okay, I on it again. 3 NMR signals. We'll continue fast. Okay, if you have not understood this topic, I'll just explain in detail. You can easily understand. See, let us take an simple example of methane. See here how many signals are there? Here only one signal, because Here all the four hydrogens have the same neighboring atoms and attached to the carbon, so it is same. Here all the four protons, here there are four protons, but all are connected to a same atom and same neighbors on the all sides. They are equivalent because they are in same environment. Okay, so that only one signal. See, remember, equivalent protons have one NMR signal. Okay, I think so I've understood. If this contain only one signal, parts per million, it contain only one signal. Okay, next we'll go with another one. It is same with ethane. 6 protons, all equivalent, therefore one NMR signal. See, in ethane also, here the carbon contain 3 protons, carbon contain 3 protons. There are equivalent and same neighboring atoms and same atom it is attached. So only one signal, only one NMR signal. We'll take one another different example. See, bromoethane gives 2 NMR signals because protons of the CH2 group become closer to the bromine are different from those of CH3. See, these protons are different from these protons because these protons are closer to the bromo, means bromine. These are far, so that there are 2 NMR signals. I think so I've understood. There are 2 signals, one from the CH3 protons and the other from the protons of CH2. We will understand by the examples, you will just understand the concept. Overall, see, propane and butane gives 2 signals. How? See, propane, CH3, neighboring atom is C. This is okay. This CH2, but neighboring atoms are 2 atoms and this is different. We can see these 2 are similar because carbon is attached with 3 carbon is attached with 3 hydrogens, here carbon is attached with 3 hydrogens. Besiding is CH3C, CH2. Besiding is CCH2. So that these two are similar and this produces one signal and this is different and this produces one signal, so that total 2 signals. Here also see, same in butane. Here these two are similar and these two are similar. Okay, so that 2 NMR signals. Okay, now we'll go with some different compounds. TMS. Okay, see, Si, these contain all the environment, neighboring atoms, neighboring hydrogens are similar, so one signal. See, here tell me, here 2 signals because these protons are different from these protons, so A equals to A is not equals to B, so that's 2 signals. See here, CH3, it contains 1 hydrogens and these hydrogens are different because the neighboring atom is oxygen, here neighboring atom is carbon, so they are different, so 2 signals. Okay, A and B are chemically equivalent. See, they are both similar but the neighboring atoms are different, so 2 signals. CH3, C double bond O, CH3. See, here A and B are equal, contain only same neighboring atom, so 1 signal. I think so I've understood the topic. If you have not understood the topic, right, just ask me, I will just tell you. See, this is your homework. Tell me the 5th one, how many signals are there, and tell me the 6th one, how many signals are there. 7th one I just showed you. See, CH3, CH2, NH2. Here contain A proton, this proton, this proton. These are different. See, this carbon is different from this because it contains the neighboring atom is carbon, but it contains 2 hydrogens. This is different. And here it contains nitrogen and carbon. Here this is very far from the nitrogen, this is very similar, so that everything is dissimilar and it contains 3 signals. And tell me this one also, this one A, B, C, tell me how many signals are there, so that I can understand you have understood the topic or not. By this we will complete the relaxation process and the signals of the NMR compounds. Okay, thank you guys. I think this video is bit lengthier, but I hope you have understood the topic. See you in the next video. Have a nice day. Bye.